A population is all the elements of a group we want to study, while a sample is a subgroup of such population that we use to generalize the population. A variable is a characteristic of a certain population or sample. There are three types. A qualitative variable is a non-numerical variable. A quantitative variable is a numerical variable. And a continuous variable is a numerical variable that can only use integer numbers. To define the number of classes that you have to use for a set of values, we use these three formulas, in which K stands for number of classes and N means the total of elements of the set of data. First, we have the empirical method, which says that K is more than 5 but less than 20. Then we have the square root method, which says that K equals to the square root of the number of elements. And then we have the Sturgis method, which says that K equals 1 plus log base of 2 of N. The central tendency measures are values that try to describe a whole set of data. We have three: mean, median, and mode. These are the formulas for the mean. First, for a sample, we use this symbol, which is an X with a bar above it. It means that the mean equals the sum of all x's, which is all the elements, divided by n, which is the number of elements that we have. The formula for the whole population is basically the same, just that we define the population as mu. A median is a value just in the middle of a set of data. You have to order it from lowest to highest and find the value that is in the middle. These are the formulas for the median. First, we have this one for the sample, and this one for the whole population, which says basically that the median is equal to n, which is the number of elements, plus 1 over 2. The mode, represented by this, is the value that appears the most in your set of data.
The mean absolute deviation measures how dispersed is the data from the mean, and the formula is this. The standard deviation measures the same thing that the mean absolute value, but there are two different processes. In the mean absolute deviation, we use absolute value to get rid of the negatives, and in this case, we use squares to get rid of the negatives, and later we get the square root of the values to get the same number. To get the variance, we only need to get rid of the square root on the formula of the standard deviations, so it stays like this way. Variance helps to see how well distributed the data is. The variation coefficient is useful to know the variability of a sample. We can obtain it by dividing the standard deviation over the mean, and if the result is near 0, then the sample is less variable, has less variability than if the result is near to 1. We also have these measures, the quartiles and the interquartile range. Quartiles divide the sample in 4 parts. So we got 1, 2, and 3 quartiles. Quartile 2 is equal to the median. Then the first quartile is equal to the median of the first half, and the quartile 3 is equal to the median of the second half. And the interquartile range is obtained by the subtraction of quartile 3 minus quartile 1, and is useful for building a box plot. We also have the percentiles, which divide the sample in 10 equal parts. And if we want to know the percentile 10, for example, we search for the piece of information that is in the 10th% of the sample.
The survey we made was a research on the number of Facebook friends each student in group 11 has. The information we got were 22 results from the students. Here we organized them on a table from the lowest to the highest. So here we constructed a stem and leaves diagram where we have our key. Our key says that one line 95 means 195, and so on.
We have 22 data, Next, we got the range, which was 958. We got it by subtracting the highest number minus the lowest number. Then, to find out the number of classes, we did the square root of 22, which is the number of data, and gave us approximately 5 classes, which are in here. And the amplitude of each class was from 204 data. And so we did this chart in which we put the frequency of each class, and then we divided the number of the frequency over the number of data to the frequency, the relative frequency. Then we got the accumulated frequency, and we did the same to get the accumulated relative frequency. Then we built an histogram with the classes and the frequencies, and so.
The next thing we did was to get the degrees each class was going to represent by using the relative frequency. So here we have the degrees, and once we had them, we did our pie chart, which represents the percentages each class takes.
Then, to make the algebra diagram, we have to take into account the accumulated frequency and put it in there, where 1, 2, 3, 4, and 5 stand for the number of classes, and this is their accumulated frequency.
Well, here we obtain mean, mode, and median, and we didn't use the classes, we used the whole set of data. The mean is equal to 10,964 over 22, which is the number of people that we asked. And the result is 498.36. Then, the mode, there is no mode since none of the values are repeating. And for the median, since there are 2 middle values, which are 427 and 430, we have to obtain their mean, which is 428.5.
Using the formulas previously mentioned, we can get the standard deviation, the variance, and the variation coefficient of our problem. The standard deviation of our problem is 246.62. The variance is 60,820.91, and the variation coefficient is, we divided the standard deviation over the mean, and we got 0.49.
In order to get the quartiles, we divided the number of data, which is 22, over 4, because we want 4 quartiles, and we got around 6. So in order to get the first quartile, we took the number that was in the 6th position. In order to get the second quartile, we got the number that was in the 12th position. And in order to get the third quartile, we got the number that was in the 18th position. Then, in order to get the interquartile range, we subtracted the quartile 1 from the quartile 3, getting a total of 343. Then, in order to get the lower limit or minimum value, we did the following. We took the quartile 1 minus 1.5 times the interquartile range, and we got a total of minus 127.5. Then, in order to get the upper value or maximum value, we did the following. We took the third quartile and we added 1.5 times the interquartile range again, getting a total of 1,199.5. We marked these two results because as our values, like the lowest and the highest, do not exceed this, we are going to leave these values as our lower and upper limits. With this information, we did the box and whiskers plot where we mark our lower limit or median or quartile 1, quartile 3, and the highest.
that the number of Facebook friends that each student has is in a wide range of data, which means that they are very dispersed. This means that the mean is not a trustworthy value, even though all the values are inside the limits.